Hello and welcome. You should be on page 27 of your pre-algebra quarter 3 notebook. In this video, we are going to be doing a review of perimeter and area. In this, we are going to start with perimeter. And if you remember, perimeter is a measure of the distance around the outside of a figure. So we're talking about the outside of a shape. The only shape that we're going to use a formula is a circle. And you may remember that the perimeter of a circle has a special name. It is the circumference. Circumference. And that circumference is the perimeter of an outside of a circle. And that does use a formula. And in fact, there are two formulas. One formula uses the diameter. And you may remember that the diameter goes across the center of a circle. The other formula will use the radius. And you may remember that the radius goes from the center to the edge of a circle. And if we were to draw a picture, I'm going to draw one right up here in the corner. Here's the center of my circle. My diameter will go across. And if I draw another circle, here's my center, a radius will go just halfway. So the formula, and I'm going to write it down here for when we get here, to use the radius, the circumference, would be 2 times pi times the radius. If I have a diameter, which it looks like I do in this one, I would use this formula. It would be pi times the diameter. Enough about circles and the circumference. Let's find the perimeter of other shapes. So a great way to help you find the perimeter is to highlight the outside of your shape. And if I look here, I've got an irregular polygon here, and I sadly don't have a highlighter, so I'm going to just use this hot pink pen to just kind of squiggle a line around the outside of the shape. And it looks like I have 1, 2, 3, 4, 5, 6 measurements to pull together. So I'm literally going to add these measurements. I'm going to add 5 plus 7 plus 6 plus 5 plus 4 plus 9. And as you can see, I crossed them off as I went along. I am going to put these 1, 2, 3, 4, 5, 6 measurements into my calculator. And once I do, why don't you give it a try? Take a second. I'll get 36. So all of these together equal 36. And now, because it's perimeter, it's just labeled with my unit of measurement, which in this case is centimeters. Let's look at this next shape. I see a triangle, and I see 4 measurements. But remember, perimeter is the outside of the shape. So I'm only looking, I'm going to highlight with the green this time, for the outside measurements. This measurement, which represents the height, is not needed to find perimeter. It looks like I'm adding 3 measurements. I'm going to add 11 plus 14 plus 20, and I'll put that into my calculator. And I get 45, and I'm going to label it with its unit of measure, kilometers. Okay, our next shape is a trapezoid. And you may remember that a trapezoid is a special type of quadrilateral with exactly 1 pair of parallel sides. This is not an isosceles trapezoid because these 2 sides would be equal. A trapezoid, again, is a quadrilateral, so there are 1, 2, 3, 4 sides. I have this additional measurement. It's the height of this trapezoid. I don't need that for perimeter. So I'm going to add my 4 sides, 20 plus 15 plus 7.6 plus 13.9. I'm going to put those into my calculator. and I will get 56.5, and kilometers is my unit of measure. And now I found the perimeter of that trapezoid. My final shape is a circle. We know that I'm going to use a very specific formula for the perimeter or circumference. I'll just write that again. The circumference of a circle. And remember, it's the outside here. I'm not highlighting it very well, but I'm looking for this measure. It does look like I have the diameter, so the diameter equals 4 meters. And we are going to use 3.14 for pi. So I'm going to use this formula because I have the diameter, and circumference will equal pi times the diameter. Well, I know that I'm using 3.14 for pi, and my diameter is 4. I'm going to put 3.14 times 4 into the calculator, and my circumference will equal 12.56, and I'm going to add my unit of measure, meters. We're going to go to page 28, and we are going to take a look at area. You may remember that area is a measure of the space inside of the figure. For area, we do need to use formulas on the formula sheet. You will be given a formula on the SOL, and you will be given formulas to use when you're taking the assessment for this unit. So let's just go and make sure we know on this page, in numbers 5 through 10, what the shapes are we see. Here I see a quadrilateral, and it is a specific quadrilateral. Looks like 4 right angles, opposite equal parallel sides. This is a rectangle. Now you can go and look on your formula sheet, and you will find that the area of a rectangle is L times W. L equals the length, and W equals the width. Let's look at our next shape, number 6. This is a triangle. And if you look at your formula sheet, you will find that area equals 1/2 times the base times the height. B, as I said when I was saying the formula, is the base of the triangle, and H is its height. Here's another quadrilateral. This time I have opposite congruent sides, congruent and parallel, but I don't have right angles. So this is a parallelogram. And the area of a parallelogram is the base times the height. Again, B stands for base, and H stands for the height of the figure. This next shape definitely looks like 4 right angles, and I have 2 congruent or equal sides. This is a square. A square, a lot like a rectangle area. I'm just multiplying length times width. In this case, it's the same. So my area equals side times side, or side squared. Because I know when I multiplied a number by itself, I am squaring that number. And S, of course, equals the side of a square. Now I have another quadrilateral. There's that one pair of parallel sides. This is a trapezoid. Trapezoid has what I consider the most fun formula, and that is area equals 1/2 I was all excited to say base 1 and base 2. 1/2 times the height times, in parentheses, base 1 plus base 2. So H still equals height, just like it has in every other formula. But with a trapezoid, I have 2 bases. I have base 1 and I have base 2. Finally, we've got our circle. And circle has a specific formula. Your area is going to equal pi times the radius squared. So remember that the radius is half of the diameter. So if you're given the diameter, you can take your diameter and divide it by 2. I should have written it the other way, excuse me. the radius will equal your diameter divided by 2. So if you're ever given the diameter, you can always find that radius. So now that I know what formulas to use and I know what all of the pieces of the formula means, let's find the areas of these shapes. Again, I've got length times width. So I'm going to tell you now in the rectangle, just doesn't matter which is which. So let's say length equals 6 inches and width equals 8 inches. Area is length times width, so 6 times 8. So my area will be 48. 6 times 8 is 48. With area, I've got 2 inches, so I'm going to inches squared. I'm multiplying 2 inches, it's inches squared. Alrighty. With my triangle, my base, my height, the height I think is easiest to find because you're going to go, well, from the base, you'll see a right triangle and it goes to that top point. Now your height is always going to be perpendicular with that right to the base. So your height is always going to come up perpendicularly from your base. So I have a base of 20 and a height of 7.4. Area is 1/2 times my base times 7.4, the height. I am going to put that in the calculator and I will get 74. And now I'm going to put kilometers squared to label it. All right, let's look at my parallelogram. A lot like when I've got a base, my height is going to be coming perpendicularly from my base. So here's the height, here's that right angle. So this helps me find my base and my height. My height is 5 and my base is 6. Area equals the base times the height, 6 times 5, and that is 30. These are meters squared. Alrighty, on to the square. Well, the square has all equal sides, so there's only one measurement to get, and the side is going to be 6.3 inches. The formula, area equals side times side or side squared, but let's just write 6.3 times 6.3, and my area, once I put that in the calculator, is going to be 39.69 inches squared. I think I'm going to do the circle first because I like to leave trapezoid for last. Let's take a look at this formula. Pi times r squared. Well, I know the radius goes from the center to the outside, so my radius is there. I'm going to use the green for my contrast, is 7 centimeters. And we're going to use 3.14 for pi. So let's put this into the formula. Area equals 3.14 times the radius, which is 7 squared. Now you can definitely put this into Desmos, but if you're going to kind of try to use your normal calculator, remember that my order of operations tell me to do my exponents first. So this will equal 3.14, and 7 squared is 7 times 7, which is 49. Now I'll put this in my calculator, and my area equals 153.86 centimeters squared. Okay, last up, the trapezoid. Remember, my height, look for that right triangle, and I'm going to find the height. Height equals 13 kilometers. That height is also going to connect my two bases. There's base 1, base 2. So base 1 equals 20, and base 2 equals 7.6. Now this is just a matter of putting this in the formula. So I'm going to have you pause it and put it in the formula. Hopefully yours looks like this. I've got 1/2 times the height in parentheses 20 times 7.6. Put this into Desmos or follow the order of operations and you will get 179.4 kilometers squared.